Welcome back. Now I just want to talk about one specific example with substitution that students often get confused by. So this one I've got y equals 2x plus 1 and y equals 5x minus 5. All right, and we want to use substitution. And what gets students confused is, all our other examples, only one of our equations had y equals. But in this case, both of them do. Okay? And they want to know, okay, how would I handle this? Well, it's not really, we don't really handle it any different. We look at our first equation and we see, okay, we know y equals 2x plus 1. So we can say, well, we can take 2x plus 1 and we're going to plug it in for y. It just happens to be that y is out there this time. Okay? But it's not any different. It doesn't change. Basically, I take this 2x plus 1 and I plug it in for the y out there. And so we'd have 2x plus 1 equals 5x minus 5. And then from there you just want to solve for x. So, get all your x's on one side, everything else on the other side. If you want to try this out, you can. What you should end up getting, I think, is x equals 2. Okay? And then when you take that 2 and plug it back in, you'll end up getting y equals 5. And so the solution will be 2, 5. Okay? But this isn't any different. A lot of times students will look at this and be like, oh my gosh, it looks different. Well, not a big deal. Okay? Just take what y equals here and plug it in for the y. Right? It happens to be out there, but it doesn't matter. Just put it wherever the y is. All right? Then the other thing, you're going to see problems like this, where we don't have the y alone. Now, normally, each year, we kind of talk about, you can get this, you can make this work. Because what could we do to this first equation? Well, what if I went ahead and I subtracted 2x from both sides? We'd end up with y equals negative 2x plus 1, right? If I subtracted that 2x to the other side. And then what we could do is we could say, well, now I know y equals 2x plus 1, and I can take that and plug it in for y. Now that works. And there are some times, if you go into higher math, where you will want to do this, okay? But I'm going to suggest that this is not the easiest way to do this. It absolutely does work. But there's actually another method for solving systems of equations that works better when our equations are set up like this. And so you could do this if you want, but let's look at the other method here. And this other method is what we call elimination. Okay? Elimination is best used when you have your x's and your y's lined up like this, and you don't have a y equals. And so if we have a system like this, this is the process we're going to use. And so let's just talk about the process. Elimination works by taking our two equations and adding them together. Okay? And what ends up happening is the equal sign stays where it is. It's right there. And we just go ahead and we add our x's, we add our y's, and we add our numbers. And let's see what's going to happen when we do that. Well, right here we have 3x plus 4x. That's 7x. Here we have 2y plus a negative 2y. Well, those are going to cancel out. Okay? And then we have 4 plus negative 18. That's negative 14. Well, look at what we have left. By adding these together, the y's canceled out, and we are left with 7x equals negative 14. Well, that's super easy to solve. We just divide both sides by 7, and we get x equals negative 2. All right? And so elimination works so well because when you add the equations together, it'll either already be this way, or I'll show you in a little bit, we can make it this way. Either the x's or the y's will cancel each other out. In this case, it was the y's. All right? And so that's how it works. And once they cancel each other out, this is super easy. All right? And that's why I like this method, is because this actually ends up being really easy after we cancel those out. Now, I just want to point out, we aren't done yet. Just like before, once we have the x value, we're not done. We need to take that, we need to plug it in. Okay? Doesn't matter which equation you put it in. I'll put it in the top one. And so we'll have 3 times negative 2 plus 2y equals 4. Right? I just took that negative 2, plugged it into the equation. And then you just want to solve that, right? That's negative 6 plus 2y equals 4. And I'm not going to go through the whole thing, but right, we'd add the 6 to that side and then divide by 2. And you'll get that y equals 5 in this case. And so our solution here is negative 2, 5. All right? And that's elimination. Now, here's the deal. This one was really nice because it already works out. Where I add these together, those y's cancel out. That's not always going to be the case. If I took these and added them together, well, 3x plus 6x, that's 9x. Y plus 5y is 6y. And so I'm not going to get anything that'll cancel here. It's not going to help us to add these together right away. So what we need to do on most problems is we first need to make it so that either the x's or the y's, doesn't matter which one of the two will cancel out. Okay? And so let's see how we do that. Well, in this case, I have 3x plus y equals 1, and I have 6x plus 5y equals negative 13. What I'm going to do is I'm going to look at either my x's or my y's, doesn't matter which one, and you want to ask yourself, what could I do to make it so that these could cancel out? Well, I see a really easy way to do it with the x's here. I see we have a 3x and we have a 6x. What if I multiplied this top number, this top equation by negative 2? Well, negative 2 times 3x, that's going to give us a negative 6x there. If that's the case, we'll have a 6x and negative 6x. Those will cancel. So basically what I'm trying to do is I'm looking at this and I'm asking myself, okay, what could I multiply by to make it so that this number here will cancel with the 6x? Well, if I multiply it by negative 2, that's when those will cancel. All right? Now, when I multiply this by negative 2, we can't just do it to one thing. We have to distribute it to everything in the equation. And so we'll have negative 6x minus 2y equals negative 2. And now, I can take these bottom two equations and I can add them together. Okay? The x's will cancel out. 5y plus negative 2y, that's 3y. Negative 13 plus negative 2, that's negative 15. From there, we just got to get the y alone. And so I'll divide both sides by 3. And we get y equals negative 5. All right? And that's the trick to these. I just got to make sure that I make it so that either the x's or the y's will cancel. In this case, I made the x's cancel. Now, again, we got y equals negative 5. I'm not done yet. We also have to find the x, right? And so you'd take that negative 5, you'd plug it in. Doesn't matter which equation. I'd maybe do it to the top one. So we have 3x minus 5 equals negative 1. You'd solve that for x, and if you did that, you should end up with x equals, let's see, we'd add the 5 over here. That'd give us 4, divide by 3, and you'd actually get x equals 4/3. So this one actually gives you a weird answer, and which is making me thinking I maybe made a mistake somewhere, but I'm not sure where I made the mistake, so it's possible. But yeah, you just take it, you plug it back in, just like normal. All right, let's look at another example. So this one I have 5x minus 4y equals 10, 3x minus 4y equals negative 2. Stop for a second and just think to yourself, how could we make it so either the x's or the y's cancel? All right? So hopefully you made a kind of decision of what you think you'd do here. What I would do is I would just take this top equation and I'd multiply by -1. And let's see what that does. So I got to distribute it everywhere. We'd have -5x plus 4y equals -10. And now, if I add these equations together, let's see here. 3x plus -5x, that's -2x. And then here's the trick. This is why I multiplied by -1, because -4y plus 4y, those cancel. And then -2 plus -10 is -12. All right. From there we'd solve, we get x equals 6, then you'd take the 6 and plug it back in. But the big trick is this first step, recognizing, oh, if I multiplied that by -1, then these y's will cancel out. All right. If we look at the next example, this one's not as easy. We've got 3x plus 5y equals -16, 2x plus 3y equals -9. So again, stop for a second, think to yourself, what could we do in this case to make it so that either the x's or y's cancel? All right, there's a couple ways to do this. The way I'm going to do it is, what if we multiplied the top by 2 and the bottom by -3? Let's see here. On top, we'd have 6x plus 10y equals -32. On bottom, we'd have -6x, right? We'll distribute the -3 here, minus 9y equals 27. Now if I add these together, notice I made it so the x's would be 6x and -6x. They'll cancel out. And so again, you're just trying to find a way to multiply this so that you'll get, basically the numbers are the same. One's positive, one's negative, so they cancel. We'd add everything else together. We get y equals -5. Okay? Take the y, plug it back in. And so that's the trick. That's the hardest part here. Now, if you have any questions on that, please ask me. We can go through examples together, because once you have this trick down, you're good. The rest of it's easy. But that's where I see students struggle sometimes. So I have an example for you here. I want you to try it out, and then we'll come back. We got to talk about some special cases. And after that, we're done.